Receive test number 1 is put the mobile to a car-to-car attack channel, and with a portable do a 5 count and confirm you can hear yourself. If at this point you did not receive anything at all, your radio is probably just broke altogether, especially if you don't see any kind of receive signal. This close with a portable, even if you had a completely bad antenna, you should be able to receive that. So this is just your initial test. Now for the next test, what we want to do is we want to go ahead and find a known station at a certain level. In this case, I'm going to use the weather channel. And what I want to do is I want to find a weather channel that's not a lot of places you'll have one that's for your area, and there'll also be full bars, and that's good to go ahead and go with the full bar one and listen and confirm that you can hear us fine. But if you can find an alternate weather channel that's only got a couple bars on it, and what you want to do is you want to take your portable and you want to go over the same channel in your portable and then confirm that you have about the same performance in your portable as you do your mobile. Your mobile should actually outperform your portable. In this case, my superior mobile antenna is pulling through and giving me 2 bars where I can only get 1 bar with my portable. So that's a great way of testing your receiver as well. Now we'll go to the digital test. Okay, for the next test, we're going to test the P25 bit error rate, and to do that, you want to go into your menu, and then we're going to go into System Test, and then we're going to go Receive BER. Now, when you're there, go ahead and on your portable, go to the same menu, System Test, and this time you're going to be Transmit BER, and you want to make sure that you're on the same TAC channel that you were on the mobile. And then once you're there, go ahead and hit Enter, and you'll start transmitting, and you should see your bit error rate on your mobile go to 0.00, and exit after you're done. So that's just confirming that it can successfully receive and decode all the 4 levels of bits that the C4FM is putting out. Okay, that takes care of your receive test. And reminder once again, if you don't have availability to a weather channel, you can go ahead and have your dispatcher key up on preferably, like I said, a distant repeater, not the one that's close to you, so you can get a fair comparison. Alright, now we'll move on to the transmit test. Okay, we're here at the transmitter test now, and the first test we're going to do is just a basic voice test. So once again, you're going to go over to a car-to-car TAC channel, put your portable on the same channel, and what you want to be able to have happen is you want to confirm that when your mobile mic and your portable get near each other, that you get a full feedback squeal, because if you have any kind of transmit audio, low audio issues, you'll hear yourself, but it won't be enough to trigger the feedback loop. So just make sure that when you do your test, testing 1 2 3 4, testing 1 2 3 4, that you get that full feedback squeal, and that your voice sounds good. Testing 1 2 4, and you just confirm basic transmit audio function with this test. Now we're going to go ahead and look at the power and see what kind of test we get on that. Stand by. Okay, now we're going to do a transmit test. What I have is I have my voltmeter here hooked up, and I'm measuring the voltage at my battery, or at my power connector here coming from the battery, right going into the input. And I'm measuring 14.5 right now with the engine running, and I'm going to key up and see what kind of voltage I got after I transmit. And I'm going from 14.5 down to 13.914, and that's perfectly legit, and that's basically what you're going to want to be looking for. Now you can do the same test with the vehicle off. But just remember that when you do with the vehicle off, you don't want to do a whole lot, because it's a 100-watt radio and you can kill your battery pretty quick transmitting. So here we got, once again, we got 12.3, 12.4 sitting, and then we're dropping down to 11.9, 12 when we're transmitting. Okay, that's a good level there. So the next thing that you want to do is you want to test for your current. Now that involves changing over to amps on your clamp here, and we're going to go DC, and then we're going to zero it out. And now we're going to first clamp on to our positive lead, and you can see we're drawing about a ½ amp there. Now I know this video is about not using a watt meter, but I wanted to put just a watt meter on here to show you, to give you confidence. This is a 100-watt radio, and I'll show you it measures 100 watts on the watt meter. And the other thing I want to show you for the watt meter is the current draw. So right now I have it hooked up to the watt meter in a dummy load, and when I key up the radio, I'm drawing approximately 20 watts. 20 amps, and I'm putting out 100 watts. And you can see on the watt meter there, that's a solid, legitimate 100 watts. So 100 watts or 20 amps. So just kind of get that basic figure in your head about the 20 amps is 100 watts. It's kind of a good way to look at it. Now the thing that I want to show you here that's going to be different on the vehicle antenna is that when I come over here and I measure the current coming into the negative side of the cable, and I key it up, I get the same exact current, 20 amps, 19.9 amps. And the reason is because it is the only path of current that this thing has. Now you're going to see that when I hook up the antenna to it, now it's going to have access to a different ground. So it's going to make a parallel circuit, and this is how you're going to know if you have a good radio ground, and that is how much current rides on the braid on your coax cable. So, and we'll measure that, and we'll see that those two add up. The braid DC current draw and the negative DC current draw will add up together to make what's going into the positive. So let me take the watt meter and dummy load off and hook up to the real antenna here, and you'll be able to see. Okay. Alright, so let's go back to the positive one more time. You want to key it up, and there's our you see we're dropping off some because our antenna is not as perfect as the dummy load, so it backs down a little bit. So we're getting 18.6 amps now. If we come over here and look at the negative, we're getting 16.8. So that tells me that there should be about 2 amps riding on the coax. So let's take a look at it. and then we got a 1.5. So we got 1.5 on the coax. We got 17. Oh yeah, there you go. 17 on the negative, and that should give us 18.5 on the positive, and it does 18.5. Okay, beautiful. So you can see the two currents add up. If you had a poor ground, you would see a lot more current going through your coax here. And another thing to be mindful for is you can actually turn your radio off and confirm, and then go look at the current flow through your ground and or your coax after your vehicle's turned on and all the lights are running and all the accessories. And it's a way of seeing whether you have bad grounds in your vehicle, because if you have a really good ground on your radio, all the vehicle accessories will try and ride your ground back to the battery. So you'll see current drawn here when the radio's not even on, because it's getting a current path coming from the coax through your ground connection. So you're essentially grounding the whole cab of the truck and all other devices. Okay. Next is going to be the digital test for the transmitter. Stand by. Okay, we're going to do the digital test for the radio. So what we need to do is go into the menu, and we're going to go into system test here, and we want transmit bit error rate, and it's running. Let me exit that. Wasn't ready for it. Try it again. Okay. What I wanted to tell you first was have on your portable, go to the same menu, system test, and this time we're going to select receive bit error rate, so that when we start transmitting on our mobile, we'll be able to confirm that it's putting out the signal to give us all zeros on our bit error rate on our portable. So here we go. We're there. We're ready for it. Okay, it's transmitting, and you can see we're now getting 0.0% bit error rate on our portable, so that means we passed our test. Alright, so that concludes it for the transmit test. Now we're going to do a basic antenna check. Hey guys, our first check that we're going to do is we're going to unscrew the antenna connector from the radio, and we're going to check for continuity between the ground and the ground of the radio and the shield of the cable, and we want zero resistance between those. So we're just going to do a quick test, and you see I got 0 ohms resistance, and that's what we're looking for. So the next test that we're going to do is we're going to test to see if there is a short between the center contact and the shield. And what we're looking for is infinite resistance. We shouldn't see any kind of reading whatsoever. It should be OL the entire time. We're running a quarter wave antenna, by the way, so we don't actually have any kind of coil that would give us a reading there. So you want to definitely look for a short. Now the next thing you want to do is, assuming you got no short there, is you want to go ahead and use your alligator jumper here to short the shield to the center conductor of your coax. Alright, and now you're going to take your ohm meter and you're going to go up to the roof, and you're going to unscrew the antenna, and you're going to measure the resistance from the center contact to the shield, and you should see a couple ohms resistance for the cable rod that it has to come down and go back up. If it's anything more than a couple ohms, then you got some kind of problem with your connection between the two. Now, the reason that I didn't do a whole lot here on the antenna is because the BK radio itself has a really good SWR alarm. So what you want to do is make use of that and just confirm. Well, first thing you can do is just unplug your antenna like I have it here, and then key up your radio, and you should see it immediately go into shutdown saying it's got bad VSWR, and it'll give you the continuous alarm. It'll say PA VSWR fault, transmit disabled. So you know right away that circuit is working like it's supposed to. Now what you can do is you want to go to two channels that represent the extreme ends of your frequency spread. So in my case, it's I have two TAC channels that are right next to each other, and they go from 150, basically 151 is one of them, and the next one's 159, and that kind of represents my general transmit spread. So I'll give a good 10-second push to talk on both of those to make sure that there's no issues. And like I said, if my antenna is not cut right and it's not tuned to the right center frequency, I'll get an alarm on one of those two channels. Might not get it on one of them, but I'll get it on the other, depending on the cut. So all right, well, that's your basic checkout. Now, of course, the final checkout will be a radio check with your dispatch, and make sure you're on your right repeater when you do that. Okay, I hope this helps, and we'll talk to you soon.